Welcome to solverfy.
Hello there. In this exercise we need to count how many bit strings of length 8 either have 3 consecutive zeros or 4 consecutive ones. So this could be kind of difficult to calculate, but let's do it. When you have either or the let or the word or, that means that you need to count two events in this case. Okay, so I'm going to label by the letter big O. So it's going to be the number of strings, okay, that have three consecutive zeros. By the letter I, I'm going to denote the number of strings, okay, that have 4 consecutive ones. And we need to calculate O union I, right? O or I, right? Or yes, the union of these two numbers. And this is going to be equal, okay, to O plus I, that is the number of strings that have 3 consecutive zeros, the number of strings that have 4 consecutive ones, and minus the intersection of these two events or sets. Why the intersection? What is this element, this set, what this number? It's going to be a number at the end. So O intersection I, it's going to be the number of strings that have 3 consecutive zeros and 4 the 4 consecutive ones. So we need to calculate the number for each set separately. So let's start with O. So for O, that's are the strings of length 8. Remember, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Yes, 8. So here we have our 8-bit string. Okay, so this has length 8. The point is that we need to count how many strings have 3 consecutive zeros. Okay, so how to do this? Well, we can group this in just one element. Okay, we're going to take a group of the 3 zeros, and in that case this 8-bit string is going to transform into a 6 no, into a 5. 1, 2, 3, 4, 5 no, 6, yes, 6 positions, okay, where one of those elements, and here we can put one special element that's going to be the group of the 3 consecutive zeros. So this we're going to consider the 3 consecutive zeros as just one element, okay, and this element, you can see, it can be in 6 positions. So we have here 6 possibilities to put these 3 consecutive zeros, and once for each when we fix the position of these 3 elements, then the remaining ones that are going to be the 5 positions are free. So these are free positions, and there we can put any number 1 or 0, right? So that means that here we have 2 possibilities, 2 possibilities, 2 possibilities, and 2 possibilities here. So this is equals to 6 times 2 to the 5 power. So O is equals to 6 times 2 to the 5 power. Now in a similar way we're going to calculate the value for I. Okay, this in this case we need that in our or 8 length string 1 2 3 4 5 6 7 8. Now we need to have 4 consecutive ones, right? So here we start with an 8-bit string, right? 8-bit string, and we are going to transform this into a 5 positions. 1 2 3 4 5. Why? Because again we're going to group this set of 4 ones, so these 4 ones can be in each of these 5 positions, okay? And we're going to consider as just one element. So we have 5 possibilities to fix these 4 ones, and then we're going to end with 4 positions that are going to be free for the rest of the numbers. So these four free positions are going to be either 0 or 1, right? So this is 2 possibilities, 2 possibilities, 2 possibilities, and so on. So this is 2 to the 4 power. So I is equals to 5 times 2 to the 4 power. And now we need the intersection. So the intersection of O with I, it's going to be a string 2 3 4 5 6 7 8 that have 3 consecutive zeros and also 4 consecutive ones. Okay, so you can see that here we're going to repeat the procedure as in the previous cases. So here we have an 8-bit string, but we can transform this, you can see, into a 3 places. Why? Because these 3 consecutive zeros can be in this position or can be in this position here, right? And the ones are going to be there in the same place. And always we end with a free, only one place that is free of choice. So this could be either 0 or 1. Okay, so we have 3 possible positions where we can locate this triplet of zeros, or this fourple of this fourtuple yes, that's better, fourtuple of ones. Okay, this group of ones that are 4 consecutive ones. So they can be, so we have 3 positions, one that is free, and we can arrange the zeros in this way or in this way. So we're going to call these O's, the zeros, and the ones. So let me put this in a better way. So we have 3 positions, and let's see how many combinations of positions we have. So the zeros can be here, and then the ones can be here, and then we have here this free position. Also, the zeros can be first, and the ones can be at the last position, and this I'm going to label with F the free choice, right? The element of free choice here. Or they can be at the end together. Here the zeros. Let me put with a different color. Let me see. Yeah, this. So we can have the zeros here and the ones here, and this position is free. Each free choice has 2 elements. Okay, you can have 2 possibilities or 2 ways to put numbers there. 2, 2, 2, and here. So the total number here of possible choices is 6, right? But we need to be careful because we can interchange these 2 positions. We can put the ones first and second only the O's. So for each of these one we have 2 times, 2 other arrangements. So the double. So 2 times 6. And this is the number of the intersection. And now we can calculate what we want. So all these strings that are either have 3 consecutive O's or 4 consecutive ones is equal to O plus I minus the intersection to eliminate the double counting. And this is equals to 6 times 2 to the 5 power plus 5 times 2 to the 4 power and minus 2 times 6. And the result is equals to 260.